Okay, some review of circle trig. Today I want to talk about how you know that x is cosine and which one is sine? Sine's y. Sine y. Remember that. Sine y. So if I ask you to look at this picture and just tell me what is the sine of pi over 6, you could just find pi over 6, which is right here, and the sine of it is right there. So sine of pi over 6 is 1/2. Could you have gotten that from a drawing? Absolutely. Once you knew it was pi over 6, you could have gone, oh, I know that's 30 degrees. It looks kind of like this. And then I could draw the picture. And if I know this is really 30, then I know this is 1, 2, and the square root of 3. And sine is opposite over hypotenuse, 1/2. It just takes a little longer. If you've got the chart memorized, this whole chart, you'd be able to say that really quick if you had a photographic memory. Okay? Same idea. Now, knowing what I just told you, what is the tangent of 5 pi over 4? Well, I told you sine and I told you cosine. Do you remember what tangent is? Tangent is y over x. So where's tangent of 5 pi over 4? Well, here's 5 pi over 4. You could do that by going 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Okay, 5 pi over 4. And the tangent is the y over the x, that's that over that. And what's the answer? 1. So if you took a calculator and it was in radian mode and you typed in tangent of 5 pi over 4, it would equal 1. All right. Next, the all students take calc thing that's in red there. So would you please think for me, where would you be if you were in the spot where tangent was negative and so was cosine? Tangent and cosine are both negative. Can you tell me where you would be? Tangent and cosine are both negative. You're right. Because the only one that's positive in this zone is what? Sine. So tangent and cosine must both be negative. All right, how about this one? Cosine's positive, but sine's negative. Cosine's positive, sine's negative. Can't be here, can it? Because everything has to be positive in there. Sine's negative means it can't be here. Cosine's positive. Ooh, that's this one. And sine is also negative in there? Yes, it is. That's it. All right. Next. If cosine of theta was negative 3 over 2, and tangent of theta is greater than 0, that's another way to say positive, right? Then you should know where to draw that triangle. You should know 2 of the sides in that triangle. And you should then be able to figure out how many degrees it is. Go ahead and give it a shot. It's like an R3 level. Oh, this comes down to drawing me a triangle. Okay, so here's what you should have done. You should have drawn yourself a circle, and you should have realized cosine's negative, so I can't be here. And all students take calc. Cosine's positive down here, so it can't be there. Cosine's negative in those 2 spots. But tangent being positive narrowed it down to just this one. That's where your triangle was. Raise your hand if you drew the triangle in the right spot at least. Okay, good. Next thing, the triangle itself should have had like this and a theta. And then the cosine is adjacent over hypotenuse. The adjacent is negative root 3. The hypotenuse is 2. This must be a 1. Which one's across from the 1? The 30-degree angle is. So that's 30. And if you said 30, you were really close, but you're wrong. Because it's all of this plus that, so it's 180 plus 30. Because just 30 would have been over here. We're not over there. That's not 30. I mean, this is not 30. This is 180 plus 30, 210. Did anybody have it exactly right? Okay, good. So half the class would have gotten your R3 right. That's like that. Okay, that's an R3 type question. Now, is it exactly that one? No, absolutely. You might have one where they don't tell you this part. What if they don't tell you that part? Then you have two different triangles you could draw. And then you have two different answers. That's even harder. Because they told you this to narrow it down to just one triangle. But if they don't tell you that, there's two spots where cosine could be negative, here or here. That's another spot. We could have drawn another triangle. It would have also been 30. And then the answer wouldn't have been 30. It would have been 150. Yes?
I had a third quadrant, but I just had the red 3 on the vertical line.
Because it can't be there, because why? Because it said cosine, which is adjacent over hypotenuse, from this angle, that's not adjacent. You get what I'm saying? From this angle's perspective right here, the adjacent side is this one.
Right, but I had the angle in the same place with the red 3 that's on the vertical line.
Okay, I'm going to try this again. So if you drew this like this, and you said this is theta, and it was given that was cosine of theta is negative root 3 over 2, do you get that the adjacent side has to be the root 3? Do you get that? From this angle's perspective, where is the adjacent side? A, B, or C? A. It has to go there. The root 3 has to go here. Do you get that? Okay. And the hypotenuse is the other one. Ka. Hypotenuse is 2, has to go there. You don't really have a choice on where to put that square root of 3. Okay? All right. Okay, moving on. This add or subtract 2 pi. If I add 2 pi to something, it just jumps it over. Like if I was here and I add 2 pi to it, I go over here. And notice the answer's still the same. It's still 0. Just like if I was in the giant unit circle thing and I add 2 pi to something. Second here, see if I can make a really big circle and then tap it. Woo. Okay, so this one, if I start there at 0 degrees and I do add 2 pi to it, I'm going to go right back to where I was and I get the same exact answers I had before. So it's adding 2 pi doesn't change anything, right? All right, so if I add pi over 2, does that change something? Yes. Then you got to actually be able to add pi over 2 plus pi over 2. What is pi over 2 plus pi over 2? Think of it as a half a pi plus a half a pi. That's 1 whole pi. Okay? And if you wanted to say it as 2 pi over 2, well, that's the same thing as pi, right? So 1 pi. So it's sine of pi. I go over to pi. I go up to sine. Sine of pi is 0. Another way I could have gotten sine of pi, if I go back to cancel that. Hold on a second. There were some technical difficulties there. Sine of pi. Here's pi right over here. What is sine of it? Sine is the x or the y? The y. Sine's y. So it's 0. Okay, so sine of pi is 0. All right, so what is this one really saying? It's saying sine of pi. And if it's really sine of pi, the answer is 0. This one adds 2 pi. Do you get that that's irrelevant? So it's just really sine of pi over 2. Okay. And what if I add 101 pi's? Is that irrelevant? All the 2 pi's won't matter, but there'll be a leftover pi, right? So this is like adding 1 pi. And now I'd say half of a pi plus 1 pi makes 1.5 pi's. But we wouldn't write it that way. What would we say? 3 pi over 2. That's the same as 1.5 pi, right? So it's really asking you sine of 3 pi over 2. And I could find that in this kind of a chart by going, oh, 3 pi over 2, that's right there. So where's the sine? Where's the touch? It touches right there. What's the lowest sine ever goes to? -1. So the answer is -1. Otherwise, sine of 3 pi over 2, we can go back to this thing. 3 pi over 2 is right there. Sine of it is right there. The answer is -1. Get that? All right. You're not letting this stuff pass you by because you're learning good stuff here. All right, this is the new stuff now. You'll need some place to write. You're going to need two really important graphs. I'm going to show you the parent of sine, parent of cosine, and all the little parts you'll have to get the answer right when you're asked for this in the graphing test. And then the graphing test is not the one we're having right now. The graphing test is the one we're having right before spring break. But the stuff I'm teaching you today, I'll be asking you, like they might have a graph and then ask you, looking at this graph, what is its amplitude or what is its period or that kind of stuff. So the stuff you're learning today, even though it's about the graphs, it's on this coming test. And then it's also on the graphing test, which is right before spring break. Okay, so this is going to count double because you'll see this stuff on both tests. All right, so here is sine, and we always say y equals sine of x. I don't know what that is supposed to be. Sine of x, there we go. Okay, so start by doing that. And now there's the marks that are on the x and the y-axis are super important. You start at 0, and you're going to go up to 1, back down to 0, back down to -1, then back up to 0. Okay, so how high did I go? A total from here to here was 2, but this spot right here should be labeled what? 1. And this spot down here should be labeled what? -1. Okay, next thing. Do you remember how long I told you it took for sine to complete one whole cycle? Not 1 pi, 2 pi. So this right here is at 2 pi. This right here is halfway there, right? So what should that be? 1 pi. This right here is halfway there, so what's that? Half of a pi. Not half of 2 pi, that's here. Half of pi goes here. Now I'm going to put that as pi over 2. That's a half a pi. If you'd rather say 1 pi over 2, that's the same thing as pi over 2. Okay, and then this last one's the hardest one to remember. And a lot of people say 3/4 of a pi, and that's wrong, because it's more than 1 pi. 3 pi over 2, or 3 over 2 pi. Yep. All right, so there's all the spots you would need to be able to get this one right. Okay, that's the parent graph of sine. Now, of course, this class isn't a super easy class, so you're going to have to know a lot more than just that, but that's how you start. And then we're going to stretch them, and flip them, and move them, and all that stuff. All right. Before we do that, let's make sure you understand cosine. So let's make a separate graph. On a separate place, you want a separate graph for this one. Make cosine. Cosine does not start at 0, it starts at 1. But just like sine, it goes back and forth between 1 and -1. And so, over the course of the same 4 marks, do you remember making 4 marks last time? We had 2 pi at the end is where it finished. And then pi here. Why don't we label those now? And then what's half a pi? Yep, or half pi, or you could say pi over 2. And this one's half a pi, 1 whole pi. And the way it would probably be better if I said 1 pi over 2. 2 pi over 2 is this one. But you don't really need the 2 and the 2, right? 3 pi over 2 is this one. Or just memorize it. Okay. Then this graph for cosine starts at 1, goes down, hits 0 right exactly at that hash mark. Then it's going to get all the way down to -1 when I hit down here at pi. I'm going to number that here and go over and put -1 over here. So it goes all the way down to -1, and then take a wild guess what it does. Goes back up again, and it hits 0 right here. And then it finishes by going like that. Okay? Mrs. C, I need your full attention. Thank you. All right. So do you get that cosine has the same exact numbering on the x and y axis? But the picture looks different. Sine would have been like this. Do you remember what tangent is defined as? Y over x, which is really like cosine over sine. No, sine over cosine. So if you took sine divided by cosine, sine's the green one, divided by cosine, you could get tangent. When I have it at this spot, for instance, sine is 1, cosine is 0. What's 1 divided by 0? Undefined. So tangent has a bunch of undefined spots in it. Tangent, we're not even going to talk about today. Looks really weird. But sine and cosine look just like each other. Okay? All right, next. Do you remember when we took parabolas, and then the next step after making parabolas is we shifted them, like left, right, up, down, stretched them, flipped them. You remember that stuff? Okay, I think you have a question first, though. What's your question? Is something important there? Yes, because if I divide, remember it's sine divided by cosine, and if they're the exact same thing, what's anything divided by the exact same thing? It's equal to 1. So at that moment, tangent's equal to 1 when these two are crossing. It's a good question. And if one of them's negative and one of them's positive, then you can have the answer be negative, right? Wait till you see the tangent graph. We'll talk more about it then. Tangent, it looks kind of crazy. It's got undefined spots in it. It's a big swooping graph that goes forever in one direction. It's undefined. It goes to infinity in some spots. All right, anyway, moving back to where we were here. This is brought up now because your problems are going to look like this. A sine of, let's not use the number, let's use like 5 sine of x minus 4. And you got to understand what to do. This is like a stretch. Just like, remember this is 3 times taller? Remember that? Remember that this is moved which way? To the right or left? Right 4, and then this would be moved where? Up 7. Okay, same idea. This is the sine graph, except 5 times taller. So instead of being a nice normal sine graph that looks like this, 5 times taller means it goes woo, 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 woo. Okay? And then, what's that mean? Shift it to the right 4. So I take the whole graph like this, and I move it to the right 4. Now how far is 4? Well, in this case, we have a different vernacular for that. You need to copy this down. Probably the most important formula of the next month. Put a little star by it in your notes because it's that important. Y equals A sine of bx plus c plus d. What does the plus mean? I guess I would think of it this way. Remember when we had this? Y equals A times x squared plus, or x plus h squared plus k. Remember that kind of a graph? And then it was like, this means move to the right or left. This means move up or down. This meant stretched. Same idea. We're setting that up for our sine graphs. These are called sinusoidals. Any graph that has a kind of a sine shape, it's called a sinusoidal. Good question. I haven't explained all these yet. This one's the amplitude, which is like how high the graph will go. And normally it's 1, as in it goes up to 1 and down to -1. This is the horizontal stretch. And it also tells you this part. The period comes from that B. See, this B right here will tell you if you have to change the period on your graph or not. Normally they start out as 2 pi. That's a normal. That's the parent one. But sometimes the period, the time it takes to like complete a full cycle, gets to be less or to be more. And the B tells you what to change the period to. You take 2 pi divided by whatever B is. The next one is a phase shift. This means the whole graph needs to get like shifted over. So like, again, if you have sine, looks like this, and you do a phase shift to the left, you just shift the whole graph to the left like this. Okay, so that's a phase shift. And the last thing is a vertical move. Like, let's say we were trying to write an equation for a bike tire, and there's this nail in the bike tire, and they're tracking it over the course of time. Do you get how if I take this whole graph and move it up here, that the nail would sometimes be right at the ground, and sometimes the nail would be at the highest point of the tire, like, you know, like it's going over the top, and sometimes it would be in between? This is like an example of a graph of a nail and a bike tire. And when the nail is down here, that means the nail is pretty much touching the ground. You get how that would sort of be a sinusoidal? The bike tires, the nail in the bike tire is only going to go up to like 2 feet off the ground when it's at the top of the bike tire. And when you keep riding the bike and the nail goes down, hits the ground, the nail's on the ground. It's going to keep going back and forth between those two. All right, even if you don't understand that yet, that's all right. That's going to come later. But right now, you just got to get this formula figured out. So if I give you one now that looks like this, y equals 4 sine x. I'll keep it really simple to start with. Do you get that that's a normal sine graph except what? The amplitude is 4, also known as it is stretched 4 times taller. So again, here's normal sine. Here's the new graph. Okay? This, the blue one, dotted one, that's the parent of sine. Do you get how I made it 3 times taller? Here's the just making it 3 times taller. It looks like that. You get that? Do you get when I say minus pi over 2 that I'm moving it to the right? To the right means the minus. Pi over 2, that's this distance right here. So if I want to move it to the right pi over 2, I grab my whole graph, I move everything to the right that far, and now there's my answer. Okay. So, here is a typical question that you'd have to do. All right, everybody, I know you made your nice pretty sine graph before. Now you got to make one that's a little more rough because we're going to be changing it. But the way you always start graphing, like if I asked you to graph y equals sine of 3x, you wouldn't start by graphing 3x. You'd start by graphing sine of x. So everybody just graph sine of x again on a separate graph. And see if you can remember what little labels go on each of these notches. Okay, you need to participate with me on this. Your calculator's not going to do this for you. Make the graph, make the little notches. I don't want you to get lost. I hope you know this is 1 and -1. Those are pretty easy. Then I hope you know it ends at 2 pi. And from there you can deduce all the other ones. If that's 2 pi, Grant, what's halfway there? And then half of that. Pi over 2, good. And then this is the hardest one. 3 pi over 2, very good. 1 pi over 2, 2 pi over 2, 3 pi over 2. Okay. Anyway, so now, I've drawn my original. What if the real problem was to do sine of 3x? Then the first thing you should do is remember that little formula that told you how to figure out the new period of this thing. You say period equals 2 pi over 3. Because b is 3. So now the new period of this thing isn't 2 pi anymore. Do you get how I have to rename this spot right here 2 pi over 3? All right. Maybe some of you aren't getting what I'm trying to say there. I'm going to change this just for a second to say, what if I was doing 4? Because I think this will make, well, maybe even 2. I'm going to try 2. I think that'll make even more sense. Okay, if I put a 2 here, then its period would be 2 pi over 2. Do you get that the 2's would cancel and my new period is pi? Then do you get, I can't have this be 2 pi anymore. To make this thing shrink, we have to renumber it, and now my whole cycle has to get completed by pi. So, because the new period is pi. I got that from the formula, period equals 2 pi over b. All right, so now this 2 pi has to turn into pi. If this turns into pi, what does this turn into? Pi over 2. And if this is half of pi over 2, this is going to be pi over what? Pi over 4. And then this is the hardest one to do again. But think of it this way. 1/4 pi, 2/4 pi, what's that? 3/4 pi. And now I have renumbered my graph, and now I don't have to try to sketch what does it mean to shrink it and make it twice as narrow, because I've relabeled it instead. And now by the label I can tell it finishes by pi. And I've made my period into pi now. Yes, sir?
When you did that one before, pi over 3,
Yep.
how would you shrink that?
I'll show you one of those, but I wanted to start with an easier one. So let's do one more kind of medium hard one. Y equals sine of 4x. So make a quick sketch of sine. This should get faster and faster as you get good at it. See how fast? 1, -1, 2 pi, pi over 2, pi over, sorry, not pi over 2, 2 pi, pi over 2 goes here, and 3 pi over 2 goes here. Okay, there. You'll get fast at those. Now, sine of 4x. How you change this is you use this formula, period equals 2 pi over b, and b is 4, so I put 2 pi over 4. And so do you get the new period now is pi over 2, because that's what that's equal to. Okay, so then this can't be 2 pi anymore, it's actually pi over 2. And then I go back to here and say this isn't pi anymore. It's half of whatever 2 pi was. Or sorry, pi over 2. Half of pi over 2 is pi over 4. And this is gone. And I take half of pi over 4, and what's that? Pi over 8. And then I go 1/8 pi, 2/8 pi, 3/8 pi, and this would be 4/8 pi. 4/8 is the same as 1/2 pi, right? See how I counted up to figure out this third one? I counted up from 1/8 pi to 2/8 pi, 3/8 pi. All right, so now that I got that relabeled, that's the final answer. I don't have to resketch the graph at all. I just change the labels. All right, somebody's smart. If I put a 3 in here, what would change on my graph? It'd be 3 times taller, right? So what numbers could I change? The 1 and the -1. And they could now turn into 3 and -3. You see how I didn't have to actually change my picture? I just changed the labels. Because now when I go up here, I can see, oh, I'm getting to 3. See? 3. I'm 3 times as tall as I used to be. So when they change this number, you change these numbers. When they change this number on you, you change these numbers. What if they put a negative in front of the whole thing? Well, you can't just change numbers to fix that. You flip the whole thing. So now you just redraw the graph exactly upside down from the way it used to be. See? All right. I know that was intense. There's a lot to learn there. One last thought. Okay, here's one that's been done. Do you get that they graphed the parent one first? And that's the red graph. And it used to have a period of 2 pi, but it doesn't anymore. The new period here is, if I take a 3 here, I'd put a 3 down here, and my new period is 2 pi over 3. So I put 2 pi over 3 right here. This is kind of harder to figure out what's half of 2 pi over 3. But it's not that bad. It's 2 pi over 6. It's half of that. And how do I label this one? Well, it's half of 2 pi over 6. It's 1 pi over 6. And then you can count it up to figure out this third one, and you go 1 pi over 6, 2 pi over 6. What's that one got to be? 3 pi over 6. Why isn't that 4 pi over 6? It is. It's just reduced. And some smart person, if I change this to a 9 right in front, what would I have to do on my graph? Make this the 9 and a negative 9. Good. Okay? All right. So, I know it's kind of challenging. I think it's going to feel a lot better when we get the first one of your homework done. So I'm going to do that first problem with you together. The assignment is a worksheet about what I just taught you. And right now is your best chance to do a good job on it because it's all fresh in your mind. 2, 3, 4, 5 of them. 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4.
Are we allowed to ask you questions?
2. I can't help you with those. I could help you when you're done, like when you've turned it in. Now, just a quick shout out to the juniors. Remember, if you've got this done today, that's awesome. It's going to save me a ton of work because anything that isn't done by today, I have to hand enter into a computer, and there's like 50 questions, and it's going to be a real pain in the butt. But if you haven't done it by today, you have to do it by Monday. Got it? It's not going to go away. I did put it online. I also have copies right here. So anybody that didn't go do it last night, I did put it online for you, but I know some of you didn't go look for it. Get a copy of this. Get it done over the weekend. You've had like a month. So if you've got it done, I'll take it, but not right this second. Just give it to me in a little bit. But if you need to get one of these, why don't you raise your hand right now and I'll fire them back there. So you can put 3 in this row. Anybody else that needs one? Anybody in this row? 1? Okay. Yeah, I know I'm recording. It's kind of a pain. I'm going to pause it for a second. Okay, so now I've got you your packets. The homework for today, it says 4.4a. 4.4a, number 1. I think I started it in the other. No, I guess I didn't. Okay. I didn't save that part. So here we go, number 1. It says, analyzing the graph of the sine function. Suppose you have the graph of y equals sine of x. What are, gentlemen, what are the x-intercepts when we look at the interval negative 2 pi to 2 pi? All right, everybody go off to the side on your paper and sketch this. Draw a big, long xy axis. This is problem number 1. You are graphing sine. But we usually started at the origin right here, right? And we go up and then back down and then back up again. There's sine. But we need to graph it all the way from negative 2 pi to positive 2 pi, which means basically we need to go back here and go like this. Get what I'm saying? This is to 2 pi. Negative 2 pi would be over here. So there's a quick sketch of that. Now, the first question. Pausing. Okay, so we've got it sketched, and now the first part, part A. What are the x-intercepts when we look at the interval negative 2 pi to 2 pi? X-intercepts are these things. Wait. Somehow my marker stopped working there. There, and there. There's 5 answers. What are they? Negative 2 pi. What's this one? Negative pi. What's this one? 0. What's this one? Pi. And last one's 2 pi. There we go. There's your x-intercepts. Okay, next part, part B. What is the y-intercept? Ooh, that's easy. There's only one y-intercept where it touches the y-axis. You can find it, I'm sure. Next one. Where on the interval negative pi to pi is the graph increasing? That means from negative pi, which was right here, to pi, which is right here, in the green zone, so to speak, where is it increasing? Well, it's increasing right here, but how do I say that? From where to where? From there to there. That's from negative 1/2 pi, or pi over 2, to, so this is an interval now, so you're right at something comma something. From negative 1/2 of pi, but I'm going to put pi over 2 because that looks prettier, up until positive pi over 2. That's where this would be. Oh wait, I did that wrong. It's not, I just put the spot in the wrong spot. That's pi over 2. And this is negative pi over 2. This is an interval. This is between here and here. Intervals are always parentheses. All right. Next thing. It asks, what is the largest value of y equals sine of x? What that's saying is, what's the highest that it ever goes? 1. That's it. Number 2 is exactly like that, except you've got to sketch the cosine function. Remember, the cosine function is just like the sine function, except it doesn't start at 0. It starts at 1. And then it goes down to negative 1 and back up again. And it goes all the way until it's done a complete cycle. And that's 2 pi. So there's the beginning of it. You could finish the rest of that graph. That's 2 pi, that's pi over 2, that's 3 pi over 2. Once I get started, I just can't stop. So anyway, you finish the rest of that, goes down here, etc. Once you got that sketched, it shouldn't be that bad. Let me do number 3 with you. Actually, number 3 is pretty easy. Let's do number 4. Number 4. Bottom of the page. You're going to want another free problem here. Remember, all this stuff's getting graded on Monday. Number 4. Y equals negative 7/4 sine of x over 3, or 1/3 x is another way to say that. All right. So now, always start by graphing the parent one. Okay? So I'm just going to graph the parent one. There's sine. And it normally goes to 1 and negative 1. And it has 2 pi here, and pi here, and 1/2 a pi here, and 3 pi over 2 here. Always start that way. We're doing number 4 right now. It's bottom of the front page. Okay, next. The period of this thing, who knows the formula? 2 pi over b, very good. And what is b? When I put 1/3 down here, that really means 2 pi divided by 1/3, which would be the same as 2 pi times 3. And so this would be what? What's 2 pi times 3? 6 pi. So the period is 6 pi. Do you get how now this can't be a 2 pi anymore? It's got to be a 6 pi. And that just basically times that by 3. So I can know that this gets times by 3. 3 pi is halfway to 6 pi, right? I want to copy this down. Number 4. Then halfway here is half of 3 pi, which is 1.5 pi, also known as 3 pi over 2. And then, what's between 3 pi and 6 pi? 5 pi over 2, very good. I think that, wait a minute, that might not be right. That would be 2.5 pi. No, that's not right. Thanks for trying. Nine pi over 2? Well, how about if this, I always like to count it up. This is 3 pi over 2. This is 6 pi over 2. This is 9 pi over 2. You guys that said that, you were right. You get how I counted that up? 3 pi over 2, 6 pi over 2, 9 pi over 2, and this one would be 12 pi over 2, which does reduce to 6 pi. So there we go. Okay, last thing. Who can tell me what numbers to change now? This is the amplitude. This is how high the thing goes. This is normally 1. So I change these numbers that used to be 1 and negative 1 to, yes I will in a second, to 7/4 and negative 7/4. Now I've renumbered it all perfectly, but you'll notice I left off that negative. How do I handle the negative? What does that do to a graph? Flips it. So you actually have to now flip this puppy. So how do I do that? I just take everything and go opposite of what it was. It's opposite day. And you can just go like this. And I'll know why you did that. I'll understand your graph is messy. It's okay. Pencils are better, but for the future reference. That's about as hard as they get. Okay, that's like as hard as you'd see on a test. Yes?
On the actual equation here, it's negative 7/4 sine x over 3.
And I changed it to 1/3 x.
So
That's what I'd do if I were you. Because x over 3 means 1/3 x. Okay. All right. Hopefully you learned some stuff. I know it's a Friday. You guys did a great job of paying attention, even though you're tired and